The fuel trim PID or parameter shows the deviation from perfect air-fuel ratio. This perfect stoichiometric point is 0.00%. Above equals adding fuel due to a lean condition. Below equals subtracting fuel due to a rich condition. Therefore, positive equals lean, negative equals rich. Diagnosing with fuel trims is the main way of assessing the right air-fuel ratio. The rule of thumb is that deviation of plus or minus 10%, negative or positive is allowed. That is maximum. Fuel trims is great because only the ECM knows what should be the right value. The fuel trim is also a calculated value. Whatever value of perfect 0.00% fuel trim is part of the ECM internal programming, is not published, and is different for each vehicle. Just concentrate on whether the values are between plus or minus 10%. If over the plus 10% scale, you have a lean condition, and the ECM is adding to the injector pulse to make up for the imbalance, possibly due to vacuum leaks, clogged injectors or fuel filter, or any other condition that has air or restricts fuel. Fuel trims and PID graphing are a perfect match. Once you combine these two together on a scan tool, you have all you'll ever need to find all sorts of air-fuel imbalance problems, which are about 60% of all drivability issues. For an injector driver transistor, the ECM controls the driver right at the transistor base. A pulse width of between 2.5 to 4.5 milliseconds is normal. However, pulse width is very unreliable. Always use injector duty cycle, using a simple multimeter, as the best indicator of fuel consumption. A value of 2.2 to 2.9 duty cycle tells you that the engine is running normal. A prerequisite for using any type of graphing is a good, large GUI. GUI means a graphic user interface. Oftentimes, the technician needs to be away from the PC or scanner to perform these tests with both hands. So, it is important to be nice and comfortable during these tests. Start by getting a full PID retrieval of all applicable PIDs at least once. It is a very little diagnostics value to be retrieving all the PIDs all the time. OBD2 is a request diagnostic system. This means that each PID has to be requested individually all the time, as opposed to a data packet, which is faster. Once you get a full PID access once, then you can do a quick preliminary view, and then concentrate on each individual bank of cylinders. There are the short-term fuel trims and the long-term fuel trims. Some scanners also give you an O2 sensor fuel trim. Don't get confused. The O2 fuel trim is what the O2 sensor is seeing, and not the actual calculated, off-center air fuel deviation. A quick glance at the O2 sensor is a must. Remember that the ECM's only eyes to the air-fuel ratio is the O2 sensor. Make sure that it is working correctly. a minimum of 150 millivolts, or 0.150 volts, and a maximum of 800 millivolts, or so, about 0.800 volts is desirable. Anything under 0.7 volts, or over 0.2 volts is not good. A sluggish O2 sensor will skew the fuel trims, and make you believe that there is another problem, when in fact is the O2 sensor. A close-up view of the O2 PID should put it all to rest. Again, you need as much screen detail as possible. The speed of the scan tool is also important. Newer CAN systems are very fast, so why not use the power? After testing your O2 sensor, then you're ready to concentrate on the fuel trims. The short-term fuel trim is fast reacting, while the long-term is very slow, meaning that this PID reacts to the more persistent air-fuel imbalance. Use the short-term to check for vacuum leaks, together with any other technique, such as propane enrichment using the right tool. The short-term fuel trim will always try to stay at 0. If it goes plus or minus, it will affect the long-term, and then go back to 0. Again, you need as much screen detail as possible. The speed of the scan tool is also important. The long-term is very slow, meaning that this PID reacts to the more persistent air-fuel imbalance. OBD2 is a request diagnostic system. This means that each PID has to be requested individually, all the time, as opposed to a data packet, which is faster. On screen, we can see the same procedure being repeated, but for Bank 2. In today's VE-type engines, it is very common to see only half of the engine working properly. Be aware of the fact that a wide number of systems use cross-feed injectors, so the faulty issue could be located at the opposite faulty cylinder bank. Use the short term to check for vacuum leaks, together with any other technique, such as propane enrichment using the right tool. A minimum of 150 millivolts, or 0.150 volts, and a maximum of 800 millivolts, or so, about 0.800 volts is desirable. Short-term fuel trim will always try to stay at 0. If it goes plus or minus, it will affect the long term, and then go back to zero. The fuel trim PID or parameter shows the deviation from perfect air-fuel ratio. This prefix stoichiometric point is 0.00%. Above equals adding fuel due to a lean condition. Below equals subtracting fuel due to a rich condition. Therefore, positive equals lean, negative equals rich. The CAM, or Keep Alive Memory, also known as adaptive memory, is the cornerstone of a modern fuel injection adaptive system. The adaptive memory stores the wear and tear patterns of the different sensors, engine components, and actuators. The CAM memory has to be reset every time fuel trim repairs are done, otherwise the system will still behave as if nothing was done. On vehicles like Ford, Mercedes, and some Asians, a scan tool is not needed to reset the CAM. In actuality, the CAM factor can be reset on all vehicles by itself, given a longer period of time. This, however, may not be an option for you. You can reset CAM by disconnecting the battery and turning the headlights on to discharge the capacitors that will keep the memory going. Then after doing so, your fuel trim should be back at zero, signaling a good reset.
The ECM uses the crank sensor to detect misfires by measuring the waveform variations. Early OBD2 systems had overly sensitive software modules, which would cause lots of erroneous misfire codes. That's no longer the case. So a reflash will never correct a misfire code. The ECM uses a coarse variation and a fine variation detection scheme. This is true in all systems. This also allows the ECM to pinpoint the severity and type of misfire. Of the four types of misfires, Type A, the most severe, will cause the check engine light or CEL to flash. Misfires can come from three main sources: ignition and injection. There is also the mechanical type, such as a bad valve, cylinder rings, and so on. Misfire codes Type B, C and D are two trip codes, which have to happen twice for it to set, as opposed to Type A, which sets a code and turn on the CEL right away. Here on screen, we can see a waveform capture from the ADP Scope 1 library. It shows an actual misfire as it occurred. At minimum, a small sensor to reluctor wheel gap and a 2-volt peak-to-peak signal is needed. The frequency is the cycle time, and the amplitude is the top-to-bottom distance of the cycle crest. A minimum of 2 volts from top to bottom, or peak to peak, is needed. A sensitive flash is now very rare, but a loose or faulty crank sensor or reluctor wheel are causes of misfires. There are two basic types of crank sensors: the 2-wire magnetic, or the 3-wire Hall effect sensor. If a scope is not available, a regular multimeter can be used to perform basic diagnostics. Use the meter set to AC or alternating current. You're looking for an output of 3 to 4 volts. Don't confuse this with 2 volts peak to peak, since the meter is going to average the values all the time. Here we can see an integrated way to test a vehicle network, right at the DLC or data link connector, and using a DLC electronic breakout box, or Mr. Bob DLC. The tool connects right at the DLC connector in a T-type fashion, with the ability to connect the scan tool at the back end. This allows for complete scan tool signal measurements, as well as viewing any traffic on the network. Here we see a typical Chrysler CCD, or Chrysler Collision Detection, ISO 9141 network. The ISO 9141 is part of the OBD2 family of protocols. ISO 9141 uses a two-wire topography, with the central node, the BCM. Remember, the dash module may also be used as the central node, and it may also act as a gateway. The topography is the wiring arrangement for the network. Different topographies, or ways of connecting the modules are, ring, from one module to the next, star, like the previous example, point to point, and central node. There are other rare topographies, but the ring and star are the most common ones. In this star network, with the BCM as the master node, all transmissions are regulated by the BCM. This is done so that no one module can hog the network. If one goes down, the BCM shuts it down, but this is not always so. A star topography can also be used without a central node. This is also common, and the central wire splice is used to detect shorted modules. The ring configuration is another common topography. In this case, if one module goes down, the network still works through the other connection. But if two nodes go down, then the network is gone. Cadillac and BMW use this type of network. A two-wire system tends to have a floating ground, which is not the same as chassis ground. A single-wire network uses chassis ground. In our case study, the TCM was faulty and not allowing other unrelated modules to do their job. Remember, most systems are heavily networked. A fault to the dash module may cause the transmission not to shift. There are many scenarios that can happen. In this case, the TCM or transmission module was not letting the network pulses reach a full low, floating ground level, and the other modules or nodes could not communicate. Network diagnostics require the use of many branches of knowledge, but a good place to start is by acquiring your own waveform library of good known signals. This vehicle was back to normal as soon as the TCM was replaced. This allowed all modules to be able to communicate and do their job. The road to perform network repairs is not always a clear one, but, armed with the right knowledge, it should be very straightforward.